we must admit that we are privileged and happy to see you all. We will start with the introduction of our team members here. My name is Joshua Osuka. I am the product manager, Metrohm, and also field application specialist. I've worked with F&S for 8 years and handled different product lines, ranging from titration, NIR. NIR has been our baby, latest recently. I worked with ion chromatography, electrochemistry, spectroscopy now, and I'm joined with my team member Rebecca and Sam, who are also in the call. We also have our team members also in the call. Let me have Rebecca introduce herself.
Okay. Good morning, everybody. My name is Rebecca Mozia. I am at F&S as a sales representative, currently working closely with Metrohm. And I'm glad you're all able to join today. And we look forward to a very great session together. Thank you.
Thank you so much, Rebecca. Sam?
Hello, everyone. This is Samuel. I hope you can see me. I'm glad to organize this webinar, and I hope you have a fruitful session. Thank you.
Sam is the guy behind the deck. He's doing a great job with the coordination and ensuring that we are all techno-savvy on this platform. All right, so we get to the business of the day, but before we do that, just a little housekeeping. As usual, we have the button to raise your hand if you have a question. Feel free to type your question, your concern. We'll be able to take quizzes at the end of the presentation, and we will try to keep this short and brief as possible, precise or concise, so that we get the key presentation about NIR. As I mentioned, we have different sectors joining today. We have people from milling industry, from food and beverage, edible oil. We have players from petrochemical, and I think also from commercial testing. That includes the Bureau of Standards, the Government Chemist of Tanzania. We have Kenya Bureau of Standards, Kisumu, Mombasa, Eldoret. And I believe this is a good platform to learn about NIR. Just appreciating the techniques of identification and quantification that is not chemical. I know we've done a lot of titration. We've dealt with weighing. We dealt with preparing stock solutions, and that is a bit tedious at some point. And why not think and jump to something that is non-destructive, non-chemical, easy? Just have your sample, place in a vial, and run it. That will be covered by our key presenter. But for now, just a little brief of F&S. F&S Scientific is a company in Nairobi, Kenya. We serve customers across East Africa. We have been in existence for many, many years. That is over 40 years. And I believe most of us in the call are not even 40. So that clearly states how long we've been in the market and how best we serve our customers. We cut across different industries. We have customers from pharmaceutical, oil, mining, milling, clinical, hospitals. So we have so many customers. And as we say, we broadly associated with the SDGs, the Sustainable Development Goals. And our aim is just to make Africa and the world at large a better place. So we exist to make tomorrow better than today, and we provide laboratory equipment and field-based testing solutions. These are some of the brands we manage within East Africa. And today we're probably talking about Metrohm. We cover East Africa as I've mentioned and expand beyond East Africa, going to Zambia, Malawi, and the rest of the countries within the region. And these are some of the sectors we work with, and we aspire to cover as many as possible by the solutions we provide. We have specialized equipment and technology. Beautifully, there is our product of the day, NIR, as you can see. So we say that the solutions exist, and as FNS, we'll be happy to talk to you after the webinar. Please reach out to us in case you have a question so that we can take you through our solutions and provide you with either a demo. We have a demo unit in our demo stores, in our demo lab. So we'll be glad to arrange demo sessions for the NIR. After the presentation, please feel free to book with us for that session. So that said, I just want to invite Madaliso just to say hi to us and in turn invite our presenter for the day, who will take us through the presentation as we get to learn about NIR. So sorry to mention, our sales manager, Rachel, is in another meeting. She will be joining us shortly together with the rest of the team. That is Shivam Shah, who is one of our directors, and some of our team members who are in sales. So they're having another meeting, which was a bit urgent. There's a customer issue, so they're attending to it, and then they will join us. So Madaliso, are you here? You can just greet us, also introduce Team Metrohm at MCAF, and then in turn you introduce our presenter for the day.
Thank you so much, Joshua. Good morning, everyone. It's always a pleasure to have these sessions where we interact and share more with our customers. And today will be a special session where I'll be talking about Omnis NIR. It's a new baby that we're trying to push in Africa, and it's a pleasure to have one of our very experienced Vim gangs who will take up the session. So my name is Madaliso Piri. I sit with Metrohm Central Africa. Metrohm Central Africa is the one looking after F&S and supporting F&S with all technical, marketing, and every other project that they're working on. So Metrohm Central Africa has regional offices in Accra, Ghana, and from here we have a few members who are present just to see that we support our customers and be part of this session. So without saying much, I'll allow Vim Gans to introduce himself and just give his proper introduction so that at least we get to appreciate his experience, we get to appreciate his knowledge. And please, looking forward to a successful and fruitful session. Thank you.
Well, thank you, Madaliso, for this warm introduction. I hope all of you can hear me. Well, my name is Wim Guns. I'm based in the Netherlands, working from Metrohm headquarters in Switzerland, acting as a near-infrared spectroscopy business manager responsible for the EMEA region, meaning Europe, Middle East, and Africa. I'm dealing with NIR for I'm getting more than 35 years, I guess, so quite a long time. I used to work for FOSS for a very long time, dealing with NIR spectroscopy. In 2013, Metrohm took over FOSS NIR Systems, which was the division based in the US dealing with non-food applications. At that time, I moved from the FOSS organization into the Metrohm organization dealing with NIR spectroscopy. In the meantime, we as Metrohm developed our own Omnis NIR analyzer, and that's what I'm going to talk about today. And I will now start sharing my screen, and please let me know if you can see my screen. Let's see, something should be happening now. You can see it? Yeah,
Yeah,
okay,
we can see
perfect.
it.
Yeah, perfect.
Yeah.
Okay, then let's start. I guess it'll take around 45 minutes. And I'm talking about NIR spectroscopy because with NIR spectroscopy, you will see that you can measure smarter, decide faster. What I would like to discuss in this presentation, let me see if I can come to the next slide. As always. Yeah. So what I would like to cover in this presentation, I will start to tell you a little bit about the fundamentals and the implementation of NIR spectroscopy. Once that part is finished, I will move on to, let's say, the analyzer itself. I will look into the hardware and the software. Then I will move to the application side. I will tell you a little bit about all the segments we are covering with our NIR, and I will give you some examples of typical applications. Finally, I will move into the value propositions of the Omnis NIR, things like a return on investment, and then I will end with a kind of summary. I believe after these presentations we have plenty of time for questions and answers. So please, if you have a question, please keep that to the end. Make sure that you do not forget, and then we go into that later on in more detail. Okay, one big question is why should people turn into NIR spectroscopy? Well, that's a very simple reason, because NIR spectroscopy is much faster, easier, and much more efficient. It will give you a significant reduction of use of analytical techniques which are slow, costly, laborious, or numerous. With NIR, we can do multiple parameters at once, simultaneously, and on top of the chemical properties, we can also have a look at the physical properties, things like density, viscosity, melt flow index. We can nicely follow that with NIR spectroscopy. Well, why is NIR so important? Why do we want to use NIR? Well, with NIR, there is no need anymore for any sample preparation, no need to make dilutions, no need to press tablets. No, we can measure on the product as is. We do not need any chemicals. We are just illuminating our sample, so we are also not producing any waste. And actually, the measurement itself is very simple. You put your, that's what you can see here, you put your sample, in this case it's a polymer sample, on top of the machine. You enter your sample information into the Omnis software, you push the start button, and within 20 seconds it will give you a prediction for all the parameters you have been calibrating for. In this case, we were looking at the moisture content, melt flow index, and density on the polyethylene sample, I believe it was. And all that information will be available within 20 seconds. Typically, sample preparation takes a lot of time with the conventional methods. Also, doing those analyses require really skilled laboratory technicians. With NIR, it's very simple. It's just a push on the bottom and within 20 seconds, you will get your results. This is just an example of a food sample. Typically for food, we are interested in fat content, protein content, water content. Typically done fat with a Soxhlet extraction, protein with a Kaldal digestion titration, and water with a, let's say, a Carl Fischer analyzer. Typically it takes something like 40, 30, and 30 minutes. So for all those three parameters, it will easily take you 1.5 hours. With NIR, we can do it in just 20 seconds. So you can imagine that is a big gain of time and therefore also money. Okay, well, let's talk a little bit about the fundamentals and how we can implement NIR spectroscopy. So what's happening into the machine is as follows. We have a light source, tungsten halogen lamp, looks like a lamp you have in your bathroom, giving just white light. Be careful, those lamps are specially coated, so you cannot go to your local store to buy a light bulb. You need special light bulbs for that. But anyway, that light, that near infrared light, is illuminating a sample. That can be anything, can be a food sample, that can be a polymer, it can be a petrochemical, it can be a medicine, whatever. But depending on the molecular structure of that specific sample, certain wavelengths will be absorbed, other ones will be reflected back to the detector, and that is creating an absorption spectrum. And this is a typical absorption spectrum generated by NIR. And actually, this is the only thing the instrument will do for you, creating those absorption spectra. Very fast, very reliable, very precise, and that's it. Well, with that information, we can do a lot. We can use it for identification, then we are looking much more at the fingerprint of a specific sample. Identification is an application which is typically done, for instance, for pharmaceutical companies, where they want to verify the product that's are coming into the warehouse. They want to make sure that when they have a jar of lactose, that really lactose is into the jar. Well, therefore, NIR spectroscopy is a very nice tool. However, the majority of the applications are based on quantitative analysis, and then we are looking at numbers. We are looking at how much water is existing in this food product, how much fat, how much protein. Well, that type of information is done by quantification, and then we are looking more at the behavior of increasing of peak areas. The advantages of NIR spectroscopy versus the primary method, I already have mentioned it before. With NIR, there is no need for any sample preparations. The advantage is that we are not creating any chemicals and also not creating any waste, so we have no waste removal costs. Speed, I already mentioned it before. Typically, a measurement takes, let's say, 20 seconds. So you'll save a lot of time, and you can increase your capacity, of course, a lot. Spectral changes are caused due to physical and chemical properties. So evaluation of physical and chemical properties will give you a reduction of many analytical devices, because everything can be done on the NIR. Of course, it does not mean that you not really need those primary methods anymore. Of course, the primary methods can still needs to be used to verify or to validate from time to time the NIR predictions. NIR is a non-destructive technology. We are not using the sample, we are just illuminating the sample, so the sample can be reused for other analysis. So when you look at the advantages of the Omnis NIR spectroscopy at a glance, you know, it's a very sustainable technology. We are not using any chemicals, whatever. It's very cost efficient, it's very fast, and very precise. Therefore, it means that with NIR, there is no sample preparation needed. We do not need any chemicals. We are very fast. There are powerful automation options. You can combine the analyzer with a robot system. I will show you later on. Sample can be reused for other analysis. We can look at physical and chemical parameters. Well, there are nearly no consumables. The only consumables we have is the light source, and that will last for at least 8,000 hours, and I will come back to that later on. Well, once the methods are developed, everyone can do the analysis, so even production people can do the NIR analysis, so there is no need for skilled operators, lab technicians. The analyzer, the software, is based on the Omnis software platform developed by Metrohm. So also our titrators are using the same software, Omnis software. And also it is important that nowadays you do not need to be a chemometrician to develop the method. So we have a feature into our Omnis software that will fully automatically create those prediction models for you. And I will come back to that later on in my presentation. Of course, NIR cannot do everything. There are a few things to keep in mind when you talk about NIR spectroscopy. First of all, model development. You cannot identify or quantify samples without prior prediction model development, except when you are using pre-calibrations. You know, Metrohm already put a lot of effort in developing methods for certain applications. I will show you later on what we already have done and what we will do in the future. NIR spectroscopy is not ultra sensitive. If you're looking at really, really low concentration levels, well, NIR might not be the best technology. Typically, what we can achieve with NIR spectroscopy is that when we are measuring solids in reflectance, typically we can measure from 0.1% and higher. When we are measuring liquid samples in transmission, we can go a little bit lower, let's say from 0.05% and higher. One exception is moisture. Moisture is a very strong absorber. For moisture, we can go down to, well, I have applications running where we are looking at levels around 50 ppm. But again, if you're looking at the ppb level, then forget about NIR. It is simply not sensitive enough. Of course, NIR is a secondary method. I told you the only thing the instrument is doing for you is taking those absorption spectra, meaning that you have to learn the software what to do with that information. We still require a primary method to develop the quantitative model, unless we are using those pre-calibrations, of course. As an example, if we are want to measure the moisture content, of course we need, for instance, a Karl Fischer titrator to get the primary methods done. I will show you later on in more detail how that part works. One showstopper can be dark samples. When a sample contains more than 2% carbon black, you can imagine that all the energy will be absorbed by the sample. Nothing will be bounced back to the detector, so we will not get a nice, decent absorption spectrum. And then the last limitation, I would say, are inorganic samples, like salts, metals, whatever. They are problematic because they will not give you an absorption spectrum. So for the absorption spectrum, we need OH, NH, CH bands to get the required absorption bands. This is an overview where all the functional groups such as OH, NH, SH, and CH respond to NIR light. For instance, when you look at water, you see that water is absorbing around 1900 nanometer, but also that information is coming back in the first overtone at 1400 nanometer. And even when you go further down, you also will still find absorptions around 900 and 700 nanometers. And here you see all the different groups where they act where they absorb in the wavelength range. Here you see typical spectra. You can also see that NIR light interacts with physical parameters like particle size, density. Typically, it will give you a baseline shift or give some other effects, but that also can be correlated to the real quantitative values. What you can see is that NIR absorption spectra are broad overlapping peaks, and therefore, of course, we need that chemometric software to extract the information out of these type of spectra. But again, with NIR, you will be able to do chemical and physical properties at the same time. Of course, how do we do a quantitative model prediction? Well, therefore, we need prediction models. And what are prediction models? Prediction models are mathematical models used to convert changes of spectra, what you can see here, in results. And here we are looking at water content. You see that around 1900 nanometer, you see an increase of the water peak. And that can be translated into a number with our prediction models. But for each parameter, you have to create your own prediction model. In this example, you see a sample name. You look at the moisture content, melt flow index, and density. Well, every parameter has its own prediction model. None. A few words on the procedure for prediction model development. How does it work? How do you have to set it up? Well, first of all, you have to create a sample set or a calibration set of spectra and reference values to create a prediction model. Let's say if you have a batch reaction and you want to follow the moisture content, what you need to do is you have to collect certain samples with in a certain concentration range from low to high. You have collect those samples, preferably not for one batch, but also over time from different batches to include the batch-to-batch variation, to include some temperature variations in the lab. But typically you have to select those samples, you have to measure those samples with the NIR to obtain the spectra, and then you have to take the same samples if we are looking for moisture content to our Carl Fischer titrator to get the reference values done. And then we need to link the reference values to the changes of the spectra. And then we come to the next step. We want to, we can fine tune and enhance the signal a little bit by, first of all, using math pre-treatments or pre-processings like second derivative, first derivative, SNV, D-trend, whatever we have available in order to enhance the differences. We can play with the wavelength ranges. In this case, we were looking for moisture content. Well, I know moisture is active around 1900 nanometer, but also around 1400 nanometers. So we can use these type of wavelength ranges. In this case, I used the first derivative with a segment size and a gap size. And that's how we can optimize the conditions. And then we can actually calculate the prediction model, and that will then come into what we call a correlation plot. On the y-axis we find the reference values of the samples. On the x-axis we see the calculated NIR predictions, and in the most ideal case all those dots should be on the 45-degree angle line. And this is an example. It shows you the standard error of calibration, the standard error of cross-validation, and the correlation coefficient. Well, and then of course you can validate everything by testing it with external samples which are not part of the calibration set. So this is more or less a very short how the process looks like, how to develop your pre-calibration the calibration models. Of course, we already did a lot of work for you already for some certain applications. This is an ongoing process. At Metrohm headquarters, Switzerland, they have put a lot of time in collecting samples all over the world for different type of samples in order to create what we call pre-calibrations. And pre-calibrations are data sets that can be used, for instance, when you have edible oils, to measure edible oil samples for certain parameters with a ready-to-go calibration model. It's always possible to fine-tune those pre-calibrations with your own samples to bring in your own variability of your own specific samples, but typically those pre-calibrations are put together from sources all over the world. And here you can see that we already did a lot of work for isocyanates, polyols, palm oil, gasoline, diesel, jet fuel, PET, polypropylene, polyamide, coffee, edible oils, flour, cannabis, milk powder, whatever. This is an ongoing process, so over time we will add more and more pre-calibrations available to our customers. In the meantime, we also always are working on making the existing pre-calibrations more robust by adding more samples from different sources to make it a more robust pre-calibration. And these are available. So when you are dealing with edible oils, you do not have to start from scratch. You can start with a pre-calibration and see how well that pre-calibration will work on your samples. If it still needs some fine-tuning, no worries, we can do that on that same pre-calibration. Well, we have some specifically done for food as well. And again, every time when we are releasing a new version of Omnis, we will also add new fresh pre-calibrations to the availability of our customers. Okay, so far about fundamentals and the implementation of NIR spectroscopy. Now have a look at the hardware and the software a little bit more detail. Well, this is our Omnis NIR analyzer product portfolio. You see we have 3 different versions. We have an analyzer dedicated for liquid samples. We have an analyzer dedicated for solid samples, which is measuring in reflectance. And then we also have a combined system which accommodates both sample presentation areas in one machine. Even let's say in the beginning you have only liquid samples, but maybe after 2 years you will also want to add some solid samples for reflectance analysis. No worries, our service technicians can upgrade your instrument from a single channel system to a double channel system on site without shipping the instrument to Switzerland for the required update. Everything is produced and designed in Switzerland, so we can guarantee our Swiss quality like we can do with our titrator systems. So that will give you a very high uptime guarantee on our analyzers. Let's see a little bit the inside of the instrument, what's happening inside the machine. Well, this is a picture of the combined system, the liquid and the solid analyzer in one analyzer. It is equipped with an IP54 housing. Here you find the solid compartment, the liquid compartment, and the analyzer itself. So when we are looking inside, you can see what's happening there. We have our light source there, our long lifetime lamp. We guarantee at least 8,000 hours of working time. Here you will find the internal NIST certified wavelength standard, which is needed to check the instrument, to do an instrument calibration and instrument validation with certified wavelength standards. Well, these wavelength standards can be recertified on site by a service technician, so no need to ship those standards back to Switzerland for recertification. No, nowadays we can do it on site. Here you find the 2 sample compartments. This is the solid part for liquids, so it will be illuminated from the lamp. It's illuminating the sample. The sample will absorb certain wavelengths, and that will go into the grating. This is the sample scan. This gold plate can move into the light beam for the reference scan. We do something similar for liquid samples. This is how we measure liquid samples in transmission, as you can see. And if we want to do a reference scan, we can measure through air for a compensation of temperature in the humidity, temperature in the laboratory, things like that. Then the signal will go to let's say a fiber switch, and this fiber switch determines if you are measuring the solid compartment or the liquid compartment. So in this case, you will see that we are measuring a solid sample. Then it will go to a stationary grating, a diffraction grating, and at the back end you will find a diode array in-gas detector. And that's what's happening inside the machine, and this is how we are creating our reference, our absorption spectra. Well, the robustness, our benefits on the Omnis NIR is first of all robustness and speed. It is a stationary grating, so no wear and tear. We have a one-dimensional in-gas detector, which allows for measurements less than 5 seconds if you are not doing any temperature control. It has an IP54 housing, and the lamp lifetime is, well, at least more than 8,000 hours. We have reference scans with each sample to improve the accuracy. Because it is so fast, we can do a reference scans in between every measurement. The liquid part is temperature controlled, not only on the holder, but also on the sample vessel between 25 and 80 degrees. The internal NIST standards can be recertified at customer site. Regarding convenience, we also have let's say a process analyzer, which is the 2060 DNAR with the exact same spectrograph inside. So it's very easy to transfer models from benchtop into a process environment. The sample can remain inserted when we're taking a reference scan, so it will move internally, so no need to take the sample out in order to get the reference sample done. No, you do not have to touch anything anymore. And the instrument has a relatively small footprint and is a very small size. Then we also have the option for automation. We have also a few sample robots available. We have a small one, the Robot S, and we have a bigger one, the Robot M. The Robot S can accommodate 1 sample tray. The Robot M can accommodate up to 3 sample trays. Here you put in your analyzer, and then it will fully automatically take the sample from the tray into the analyzer, do the analysis, and brings it back to the tray. You can do it for transmission vials, for reflectance vials. We are quite flexible on that. Then a little bit about the software. Omnis has 2 main versions. We have a standalone versions, but we also have a server client version for customers who have many instruments and want to control it by an external server system. It is optionally 21 CFR Part 11 compliant, which is needed for pharmaceutical industry. Omnis is an all-in-one software, including instrument calibration validation. It has routine analysis inside, how we are creating and managing methods, operating procedures. We can make our own prediction models. And a nice thing is that if you're already familiar with Omnis, with our titration analyzers, you also see that it is the exact same software platform. Even if you are using already Omnis titration and you want to expand with NIR, there is no need to buy the full software again. No, you can just buy an extra license for your spectrophotometer. Also, how it works, you also see quite often a combination of titration and NIR. Typically, what we have seen in many places that they use NIR as a kind of screening method, and as long as the predictions are in line of expectation, it's fine. However, when you find a prediction which are, let's say, borderline, then we can do automatically a titration method to validate that specific number. Then a little bit on the model development. It is quite an easy and powerful way. Well, you see 3 different parts. It starts with this sample selection part, then you can parameterize your quantification model, and then you can validate your quantification model. You have a clear display here of sample sets. Here you find the reference values. Here you find the spectra itself. And that's the first part of the model. And we also have a very nice feature which allows anyone to create models. You do not have to be a chemometrician anymore, but we have the Omnis model developer. And then what you need to do is you need your spectra and your reference values, and then you can say start OMD, and then it will fully automatically create a best model for you. Later on in this presentation, I have a very short video how shows you how easy the Omnis model developer works. It's a very precise tool. I know that within Switzerland, we have done a lot of testing on the OMD and challenging the chemometrician with the software. And 9 out of 10 times it came out that the Omnis model developer came with a better, more robust prediction model than our chemometricians could do, because this feature can play with all the different possible mask pretreatments, all different wavelength combinations, areas where to look at in order to get the best possible model out of it. Here a little bit more on the mask pretreatment, the pre-processings we have available. We have all different derivatives. We have Savitsky-Goulet, standard normal variant, the D-trend, and we have many different plots to go for an in-depth evaluation of the model. We have the correlation plot, influence plot, loading plot, score plot. It goes a little bit too far now to explain all the different things, but I would say an important one which gives you a very nice indication how well the model works is the correlation plot, and that's what you can see here. Then the routine analysis part, you can create a sample list which is displaying the results. You can prepare the sample list up front so that you not need to touch the software anymore during the measurement. The instrument has a kind of sample recognition feature, so it will prompt you to take your sample out and take the next sample in if you have created a sample list, what you can see here. Live data view displays important information, and it gives you some guidance during the measurements, temperature control. Spectra can be displayed for all measurements, and Spectra can be overlaid for fast confirmation of measurements. So many things you can do here. Again, for this presentation, go a little bit too far to go in depth here, but it just gives you an overview of what we can do. So the benefits regarding our Omnis software. It's a single software for routine analysis, model and method development, and data management. Single software for control and uses of multiple analytical technologies, titration and spectroscopy within the same software platform. It's compliant and adaptable to your needs. It has an extensive user management. It is 21 CFR Part 11 compliant for the pharmaceutical industry. We have a client server version. We can work with LIMS in 2 directions, so it's very easy working. It's easy to automate everything because of our combination of NIR, titration, and the robot systems. Okay, so far hardware, software of the Omnis NIR analyzer. Then now have a look at the application side of the business. Which industries where are we active? What have we done so far? Well, we have done a lot of work already in the petrochemical industry, looking at gasoline, when we are looking at Ronmon, and many more parameters, diesel, cetane index, cold filter plugging point, jet fuel, paralyzes gasoline, looking at diene value, bromine number. All these are pre-calibrations available. Chemical industry, well, we did a lot of work for the polyurethane industry in specifically looking at OH number of polyols, looking at NCO content of isocyanates. We have been working with several polymers like polyethylene, polypropylene, PET, polyamide, also covering a lot of parameters for these type of products. Pulp and paper industry, looking at kappa number, moisture content. Ink and paint industry, acid number, aromatics content, specific gravity of pigments. Also in the biomedical industry, we were quite successful looking at the moisture content, fat content, nitrogen content, and caloric value in stool samples, which is a very important application. At least here in Europe, we have several hospitals using NIR as a fast screening method for these type of applications. Of course, pharmaceutical industry, identification incoming raw materials, moisture in lyophilized products, blending, active ingredients. In the personal care industry, we have done a lot of work. The edible oil industry, palm oil industry, olive oil, rapeseed oil. Well, we have done it all. We have a very robust pre-calibrations of that, and I will later on will give you a specific application example on the edible oils. But also in the food and feed, you know, we did a lot of sugar canes, coffee. We have been developing wheat flour, protein, moisture, ash content on wheat flour, and many more. Chocolate, pet foods, even cannabis, we have done a lot of work. And on top of that, we are still expanding. These were just a few examples. Of course, we do a lot more. We have on top of that many, what we say, starter sets available, which are not ready pre-calibrations yet, but are available for our customers. Let's say when they have a specific application on, well, let's say grain, whatever. Well, we do have or dairy product. Well, we do have starter calibrations on dairy. You can have that free of charge. You can add your own samples to that specific model in order to get a better and more accurate results on your own samples. Then just an example of a few real applications. This is one on edible oils, what we have done. Edible oils, we are looking on a liquid sample. We want to measure in transmission, working with the liquid analyzer, using the 8mm holder and the 8mm disposable vials. We are measuring transmission. Typically, we will measure at a slightly elevated temperature in order to rule out temperature changes of the lab. And here you find a typical spectra of edible oils, how they look like. Where are we looking at for edible oils? Our pre-calibration covers a lot of parameters. Parameters we are looking at are free fatty acids, iodine value, C16, C18, C18, 1, 2, and 3, refractive index, induction time, peroxide value. These are the official primary methods, and typical instruments for the primary method were like titration, GC, refractometer, and the Ranzimat. And here you find some results. The blue dots are what we call calibration samples. These are the samples which were used to develop the pre-calibration. The green dots are what we call the validation samples. That are samples that are not part of the calibration set, but they were predicted on the calibration set. Like for iodine value, we found a standard error of calibration of 0.47, a standard error of cross-validation of 0.48, and the standard error of prediction of 0.50. Standard error of cross-validation means that we are taking out a few samples of the calibration set and predict those samples on the remainder of the calibration set. That determines the SECV. SEP, standard error of prediction, means that we are measuring samples which are not part of the calibration set, and this gives you an idea how accurate they are measured. Correlation of 0.999. So you see a very accurate model for iodine value. I dare to say we can do the same for refractive index. You see all the dots are more or less on that 45-degree angle line, meaning that our reference values are identical to our calculated values, which is a nice indication on how well the model is working. Free fatty acid content, we see a little bit more deviation here, but it's also because of the variety of the product itself. Free fatty acids, 0.12 SEC, the 0.12 SECV, and the 0.13 of SEP, correlation of 0.946. The C16, the palmitic acid, you see here the samples in the calibration set and the validation set, but also here very nice results. Same for the oleic acid and the linoleic acid. You see almost no deviations here, which will guarantee a very accurate prediction, I would say. Well, this is the overview of our pre-calibration for edible oil. It's a global pre-calibration. Here you'll find the different parameters. Here you'll find the ranges we are covering in the pre-calibrations, the standard error of cross-validation and the correlation. And here you will find the instrument configuration. This is a global calibration, but we also have dedicated separate calibrations for the typical oils. So we have a dedicated one for sunflower, for soybean, for rapeseed, sesame oil, and more. So they are also available. Another example, let's say wheat flour. That is a solid application where we are using a solid powder, measuring in reflectance, using the solid analyzer, using that big cup in order to compensate for inhomogeneity. So the big cup will rotate during measurement, so it will take scans on different positions that will be averaged out in order to get a better reproducible results. And here you find the typical spectra of the wheat flour. Sample matrix, the different parameters we have been looking at: moisture, ash, protein, gluten, starch, baking strength, elasticity index, sorry about that, and the tenacity. The reference methods and the ranges we are covering for these type of parameters. And here you'll find the results for moisture content, protein content, ash content and the results of all the other parameters you find here. So also for wheat flour, we have a very nice, decent pre-calibrations available. And again, if there is a need, we can also add your own samples to those existing pre-calibrations to even fine-tune those pre-calibration to your specific samples. Yeah, this is the pre-calibration information for wheat flour from moisture, protein, and ash, and the recommended instrument configuration. Just a few examples. I can show you 100 more, but this is just for your idea. Then let's have a close look, short look to our value proposition of the Omnis NIR and an example of a return of investment. Again, the advantages at a glance, no sample preparation, no chemicals, the availability of pre-calibrations. It's very fast. You can do fast decision making. We have, because it's so fast, you can increase your measuring capacity. Sample can be reused, not so much bench space anymore. Looking at physical and chemical parameters, no consumables, and also not also very important, it can be used by untrained operators. Some value propositions. Well, we have one Omnis software package which can be used for titration and NIR. So you only have to familiarize one software package. Powerful automation with the sample robot NIR. Well, that allows you for unattended measurements. It's very fast, so you have a high throughput. We have an active sample heating and cooling, which will allow you to ensure your reproducible measurements. It automatically detects the insertion and removal of a file, so you have a simplified workflow. No need to interact with the software anymore. It will prompt you what to do. Auto start function, same here. We have the possibility to use a flow-through cell for unattended series determinations. We have the rotating cup to compensate for inhomogeneity. We have smart accessories which will prevent user mistakes. Lamp life, 8,000 hours at least, which gives you some reliability, guaranteed uptime. And the Omnis model developer, that feature that creates the models for you. So you get an easy model development for even non-experts. Then a short example of a return of investment. Well, typically when you are looking at return of investment, you have to compare two things. You have to compare the existing method to the Omnis NIR. Important to know is that you have to be sure how many analysis do you want to do per day, per month, or per year? How much time do they take? What are the personal costs? What are the costs for reagents and solvents, consumables, waste disposal, maintenance? So all these things are important to calculate the cost of the existing methods. Then you have to compare with the Omnis NIR, and then the same, how many samples we want to do, how many time do we need per analysis, what are the personal costs, the purchase, of course, of the analyzer itself, the maintenance needed, and that you have to compare. And now I have one example for the petrochemical industry where I did an investigation in the return of investment of the Waukesha engine to determine the RON and MON of fuel samples. This is typically done by a big Waukesha engine, looking at the RON and the MON according to ACMD 2699, the MON according to ACMD 2700. This is the reference method. And here you'll find an overview of, well, the NIR compared to the Waukesha engine. And well, this is a typical example, which is the numbers are typically which you can see in a commercial petrochemical lab. Typically, they do something like 2,000 analysis per year, RON and MON. The cost of an operator per hour, let's say $25 plus in both cases. Then you have the cost of the analyzer, the CFR engine, the Waukesha engine, or the NIR. This is just an indication, of course, but you see that CFR engine is very expensive. Well, for this calculation, I assumed that the CFR is already there, so I did not put any value here. But then when we are looking at the running cost for consumables, chemicals, and maintenance for the actual reference analysis, it's about $20,000 for chemicals. Well, for the NIR, we do not need any chemicals. Maintenance cost per year for this motor is around $20,000 as well. For the NIR, let's say one maintenance, let's say $1,500, maybe one lamp, whatever. Chemicals plus maintenance cost per analysis, well, let's say $20 per analysis. For the NIR, well, maybe you need your disposable vial, that will cost you some cents, but that's it. So total running cost per year for the Vocation engine is around $40,000. For the NIR is only $1,500. Time spent per analysis, the Mon Vocation engine takes more or less half an hour. So labor cost of 1,000 analysis, $12,500. For the Mon, the same. Per analysis is $12.50 per analysis. Well, for the NIR, it's of course much less because the analysis is much faster. Typically, labor cost per analysis is less than $1. Total labor cost per year, $25,000 for the engine, $800 for the NIR. So when you add everything up, total running cost for the engine is $65,000 a year. For the NIR, a little bit more than $2,000. So even, if you are assuming that 50% of the analysis are covered by the NIR and the other 50% still by the Vocation engine, then still you will see that return of investment of the NIR is in at least less than 2 years. So that is a nice example. Just to give you an idea. Then let's have do a summary, and then I will also show you a few very short videos which explaining a little bit more. Well, I already told you NIR is much faster, easier, and more efficient. Why is it faster? Because it's a light-based measurement. You can do numerous quality parameters in just a few seconds. Liquid samples without temperature control, less than 5 seconds. Solid samples with the rotating cup, it might be 20 seconds. Temperature control between 25 and 80 degrees. And we have only one analyzer for both liquid and solid samples. And then I have a very short video that shows you, well, how fast it goes.
Are you ready? 5, 4, 3, 2, done. Watch how fast it is to measure your sample with the NIR analyzer. Take your sample, place it into the NIR analyzer. The instrument recognizes the vial and starts the measurement automatically. It takes only 5 seconds to measure your sample and provide the results for multiple chemical and physical parameters. In this case, for a diesel fuel sample. Do you want to analyze also solid samples? No problem. With the NIR analyzer, you can measure both liquid and solid samples. How long do measurements take with your methods? Request a demo now and learn more about NIRs from Metrohm.
Then, of course, easier. Well, we have smart algorithms to do the work for you, the OMD, that tool that will make the model for you if you do not have the knowledge yourself. The easy change from lab to process, because the same spectrograph is inside, and the smart recognition sensor that can prompt you to take out a sample, put in your next sample to do a kind of semi-automatic analysis. And also here I have a very small video to show you how easy it is to do the measurements.
It's so easy. Everyone can create prediction models with Omnis. This is how it is done. Select the sample you want to use and for which quality parameter you want to create the model. Start the Omnis Model Developer, and that's it. Algorithms do all the parameterization for you, and the best NIR prediction models are calculated automatically. Colors indicate the quality of your models. You can directly use the models for your analysis or get in-depth information about the model. Of course, All settings can be changed manually if needed. With Omnis, everyone can create high-quality prediction models in no time. Request a demo now and learn more about Omnis NIRS from Metrohm.
And then the last part, more efficient part, superior integration with LIMS, client server. The synergy of titration and NIR, same software platform, using NIR as a screening method and using titration to validate certain sample answers. Maximize sample throughput by using the robot system, and with the robot system you can analyze up to 231 liquid samples and or solid samples completely unattendedly. And also here I have a very short video that shows you the more efficient part.
Like this, or like this. The modularity of Omnis allows for many configurations to make your lab more efficient. For instance, combine your Omnis NIR analyzer with a Carl Fisher titrator to determine both the water content and the cetane index in a petrochemical sample. Both parameters are determined on the same platform, and the results are shown in the same window. Consolidating different technologies on the Omnis platform is one big advantage. Automation is another one. Combine your Omnis NIR analyzer with an Omnis sample robot for higher throughput, and use the same Omnis sample robot to also automate your titration applications. What you get is a fully integrated system to determine your most important quality parameters completely unattended. And which Omnis configuration would meet your requirements? Make your lab more efficient with Omnis NIRS. Request a demo now and learn more about Omnis NIRS from Metrohm.
Okay, well, so far my presentation, I know is a lot of information in a short period of time. My takeaway message to you is NIR, it's a great technology. Of course, it requires some effort from both sides, from the customer, but also from Metrohm. We as Metrohm will not try to sell you a piece of hardware, an instrument. We always try to sell you an application, a solution. Also, we as Metrohm need to believe in the application. When we need in the application, then we will make sure that we will make your application up and running as quickly and smoothly as possible. Don't try to do too many things at the same time. Focus first on your most important application. Make sure that you get that application up and running. Get familiar with the instrument, with the technology, with the software, and start let the machine earn money for you. Then you get more experience, and then of course you can roll out to all different type of applications. Well, thanks again for your attention. I hope it was worthwhile. And then I give the word back to Osuka to go to the next part of the question and answers, I guess.
All right, thank you so much. And that indeed is some good information.
Thank you.
Thank you, Vince, for the great presentation. I've been keen and been able to pick.
I will stop sharing my screen. So we're back.
Yeah.
Okay.
Very, very great take-home points from the presentation. One, about that Metrohm offers Omnis an NIR analyzer, and comes in 3 models. So we have the solid, liquid, and solid liquid. Solid, then liquid, then solid stroke liquid. Let me say that way.
The combined one. Yeah, exactly.
Yeah, the combined one. Yeah. And this uses Omni software, which is the same software used in titration. So you have one software, you can run 2 different Omnis equipment. Titration, you can run the NIR analyzer. And the beauty is that Omnis and NIR analyzer can go to different industries. So they have been mentioned, examples have been given with different calibration models already existing for different industries. And there's a lot of work ongoing, as James has mentioned. We have a lot of research going on at the Metrohm headquarters to develop more models so that we have a plug and play system. So, but the beauty also is that there is Omnis model developer. So it does not have a lot of work as we used to do with that was called Vision and Vision Air and Vision Routine for DS2500. I've worked with Vision and Vision Air for DS2500, and it was a beautiful one. I think this is more beautiful. So, by the way, for your information, we have a demo equipment here at FNS, Omnis Solid Liquid Analyzer, the combined one. And we have edible oil prediction models. We bought those, so we are doing some work here. And that means if you want to see the equipment in real action, please book for a demo with us. You come and see the equipment at our offices. And we are celebrating that this is fast, efficient, and an easier technique. Thank you so much. I want to proceed to the Q&A section. I saw one already. I think somebody had requested that we share the presentation, which is noted. We'll be able to do that. I also welcome our participants to share questions in the chat box. You can also, by raising your hand, we'll be able to see it, and then you can ask a question. And so, please proceed. I'm checking my chat box. Rebecca is checking if. But as questions come, I just wanted to check with our presenter if there is something for the fertilizer industry, because I have.
Fertilizer, yeah, fertilizer industry. We were quite successful also in fertilizer industry. I know in Brazil we sold quite a few systems to Mosaic, which is a big fertilizer company, looking at urea content, moisture content, and that type of stuff. So we have quite some experience there. We might also even have some starter models for fertilizer type of applications. So yeah, also fertilizers is a very nice application and very doable with NIR spectroscopy.
Okay, so great. I think we have
Santos has a question.
Juma from TFRA. I think this would be an interesting area for you. But even for the Bureau of Standards within the region, Kenya Bureau, I think this is also a nippy product and technology for you. We have Chris from Bull, Bitco Uganda, part of Wilma Group. He's been using DS25, I think, for the longest, and he's one of the guys with a lot of experience in using DS25. He's in the call. Chris, I don't know whether you have any question to ask or any comment, but as that goes on, we have Santos. Santos from which industry? Santos, you can unmute. Some of you able. Yeah. Okay, Santos, please.
Yes, this is Santos from Bidco, Uganda.
Hi, Santos.
Okay, great. Good to have you, Santos.
Yes, Joshua. Now, my question, I want a clear clarification from the DS500 model and this Omni. And my question is about the temperature control. With the DS2500, we have been having some challenge with more especially the temperature control. You find that in the theory, they are telling you, before you read any sample, you have to make sure that the sample is in a molten state. So, in most cases, by the time you place that sample in the reading placeholder, you find that there is a temperature variation already. But the DS2500, it doesn't have the temperature control regulation inside it inbuilt. You can set the temperature, for example, maybe at 40 degrees. But because the sample temperature is continuously varying, and we all know that the temperature is very key in giving us consistent and almost perfect.
Is it a liquid sample?
The temperature is liquid sample. And we know that the temperature is a very key parameter in controlling the result that you get, how efficient it is. Yeah. So you find that one very sample is giving you contradicting and varying results. So you end up having a lot of confusion in choosing which exact sample result you should take because of the variation in temperatures. Now my question to this new model, the Omni, Mr. Vim has talked about the temperature control inbuilt within it.
Yes. Yes.
So my question is that temperature control, does it regulate the sample temperature? Like, for example, if I place my sample and it is at 60 degrees, and I set the Omni temperature maybe, for example, between 50 and 70, does it bring the sample temperature to equilibrium with the instrument temperature, such that by the time of reading the result, both the sample and the heating mantle of the system are at the same temperature?
Yeah.
Does it do that?
Good question, Santos. And there is one big difference between the Omnis NIR and the DS2500. The Omnis NIR has two temperature sensors. It controls a temperature sensor holder. That's the holder where the vial goes in, but it also monitors the actual sample temperature. So it does both. So when you are putting together your operating procedures, you can tell when you are preparing your sample that it should look at the sample temperature. And when you put the sample temperature on 45 degrees, the measurement will start as soon as the sample temperature reach that exact 45 degrees, which will at the end give you more reproducible results. In comparison with the DS2500, the DS2500 did not have that feature. The DS2500 had only the vial holder control and not the actual vessel control. And that's the big difference between the Omnis NIR and the DS2500. On top of that, the measurement of the Omnis NIR is much faster than the DS2500 measurement. So also there you will find again that the actual time between measuring and putting in the sample is much shorter, which will also again give you a more reproducible result. But the most important thing is that with the Omnis NIR, we do have that feature of vessel temperature control, which was not available at the DS2500. I hope this will answer your question a little bit.
Thank you very much for that clarification.
Okay, top.
All right, thank you, Santos, and thank you, James, for the clarification. There's another question in the chat box from Nixon from the Pingo Industries.
Yeah, I see that question from Nixon. Thank you, Nixon, for that question. Sure, apart from edible oils, we can do many things, and also for the cosmetic industry like soap analysis, hand wash detergents. We have many applications going. Recently we sold a system to Unilever for that exact same application, hand wash detergents, soaps, whatever. We have nice starter calibrations for these applications already, maybe not ready to use pre-calibration, but nice starter calibration which can be used free of charge. You can add a few of your own samples to fine-tune the model for your specific samples. So yes, I can confirm positively, hand wash, soap analysis, we have done it, we can do it, and it's a very nice application. When you look at our website, you can also find some application notes for these specific applications. We have them available. You can have a look and see how they were done with the Omnis NIR.
Yeah, thank you so much. And we have some ongoing work. I think we should be at the Pingo soon for a demo placement, and I think we'll have further discussions with the team on this. So this is a project that we have been looking forward to, and Nixon, it will be glad to partner with you and work together in this project. Rebecca's another question?
Yeah, there's a question from Selena. Can you quantify and identify sample out of pre-calibrated example fertilizer?
Maybe
when you get the question?
Yeah, I can see the question in the chat box. No worries. And yes, of course we can do quantify, identify samples, but for fertilizers we do not have ready to go official pre-calibrated calibrations. However, we do have starter models available for fertilizers. So yes, you can use the starter models to fine-tune the predictions for your own samples, and then we can do both quantification, identification without any problem. But for fertilizers, we do not have official released pre-calibrations yet. I know headquarters is working on that specific application, but we are still collecting samples from different sources in order to include all the possible variability into the pre-calibrations. At this stage, we are not that far yet, but we do have our starter models available, which can be used as a very nice starting point. And then, of course, we can do both quantification and identification on fertilizer samples as well.
Yeah. Thank you so much. And I think we had a discussion with the TFRA, Tanzania Fertilizer, is it regulatory authority? Yeah, just 2 weeks ago with my colleague Rebecca when we visited them. And I think we started some discussion in that line. Hopefully in the next few years, they'll be able to have their Omnis, Omnis installed.
Would be nice.
Yeah. Santos is excited about the OMD. I am personally excited about this because
it's really a great tool. And again, we put a lot of effort in developing this tool. And again, I told you before, we have been challenging this tool to our mathematicians in Switzerland, and 9 out of 10 times the results of the OMD were even better than what has been done by the mathematicians. The good thing, of course, of the OMD, it's so fast, it can try every single change in wavelength ranges in mass pretreatments in order to get the best possible results. And yeah, it's a really nice tool which makes the use of NIR much more easy to implement, also for people who are not familiar with multivariate analysis. But thanks to this OMD software feature, it will do a lot of nice work for you and makes it much more easy to implement. Yeah.
Perfect. I think it will be interesting also to just get to know more about the Unilever branch that bought the equipment, because we've had some discussion with Unilever in Nairobi about this, and I think we were trying to get references from South Africa. So that was the DS 2500. So we can connect the Unilever Kenya with the Unilever plant that has bought Omnis.
Yep.
That can be a good way also to network them.
Yeah. That was in Dubai. By our Metrohm Middle East office. Yeah, but that's for that specific exact same application. Yeah.
Okay, perfect. Seems there's no any other question. We are all good. I think at that point, I will just want to extend my sincere appreciation to our participants who joined the call today, and they were able to stay put until the end of presentation. At some point, we reached 47, which is a good attendance. We're going to cascade this information to you all and ensure that all your team members are empowered with the information you're coming from this webinar with. Please be the champions, spread the information about Omnis NIR. We're moving away from the hectic analysis in the lab. We want to make every lab empowered with the power of Omnis. And yeah, see, there's another question coming as I was just closing it. So there's a question again from Santos and then David. I think you can just take up those before we close it.
Yeah, maybe I can start with Santos' question. Can you incorporate the OMT software to vision software which the DS25 models used? Well, what you can do with the Omnis software is to import the DS2500 spectra into an Omnis format. This is fully automatically done. It's just done by one push on the button to import the DS2500 spectra automatically. And then, of course, based on that sample list, you can apply the OMD in order to get the best possible model. So yeah, it's very easy to import the DS2500 data into the Omnis. We already have created a button to do that for you, so it's very easy. There's nothing special done. You just have to get to the Omnis spectra or to the DS2500 spectra. Of course, we do need the spectra. We do not only need the equation, we need a full data set. Import them into the Omnis software, and then we can apply the OMD to get the best possible model. Okay, is that clear?
Yeah, very clear. Thank you.
Okay. Then the last question from David. His question is, how can inline NIR spectroscopy be optimized to maintain consistent flower quality despite variations in wheat blend and tempering conditions? Now, the way to optimize the modeling for process is that in the process you have to, in the calibration set, you have to add all the possible variations. So when you have some fluctuations in temperature, then you have spectra to the calibration set with the different temperatures and the reference values. Variations in wheat blends, the more spectra are in the calibration set of the different wheat blends with good reference data, the more accurate the prediction will be. So I guess for process analysis, you might need more samples in the calibration set in order to catch all the possible variabilities you can expect during your process. And that's the way how you can a consistent flower quality. So you have to get all the variations that you can expect. You have to build in your model in order to make the software know what to do with these type of variations and how to compensate for that in order to get the best possible predictions. So it can be done, but it takes some work, it takes some effort. You have to include all possible variables into the model, and then you can take care of that.
Yeah, that will involve some good work from David.
Yeah, sure. That's process, that's everything that can change has to be shown to the software, so the software knows what to do with that change, and that's more or less what it means. In the process of in the benchtop or in the laboratory, it's much more controlled. Typically for that we are always measuring at a slightly elevated temperature, let's say 35 or 40 degrees when we are looking at transmission measurements. In process, that's a little bit more complicated. Yeah, I agree.
Yeah. Thank you so much. Thank you for the clarification. I saw Mr. Levi from Bitco, Uganda. As we wind up, I don't know whether he's still in the call. I'll just invite him to just say a word as we close. He's a man I respect so much. He's worked with NIR DS2500. I think the older models that I didn't even have experience with.
XDS, yeah.
You can just. I don't. Mr. Levy, are you still around?
Yes, I'm in a call. Thank you so much, Joshua, for giving me this opportunity to say something. I can actually say we purchased this machine and installed it late last year. So far, we have not had any huge problems, apart from what my colleague mentioned, and I hope you'll sort that out. And the question is now, my concern when you are looking at the cost is when you are improving on this these instruments, you should take care of the cost the companies have to bear when it comes to changing from one version to the other. Otherwise, we are okay with your technology and we will continue to support you. Thank you.
Thank you. Thank you so much.
Thank you, Mr. Levi. Thank you so much.
That's from Bitco Uganda, part of Wilma Group.
Yep.
Okay. I think we are all good there. The parting shot is let's stay informed. Let's spread the information. If you need a demo session, please talk to us. We'll be able to share certificates as requested and share the presentation. Otherwise, thank you all and have a beautiful afternoon, day, and the rest of the week. Thank you, Joshua.
Thank you, Joshua.
Okay, bye-bye.
Bye.
Bye-bye.